In this video, you will learn about probability. Now, as we begin our discussion of probability, there are some definitions that you need to be aware of. Our first definition is the word experiment. An experiment, by definition, is an occurrence that can have more than one possible specified outcomes, where the outcome depends on chance. So, for example, rolling a dice is an experiment because it has more than one possible outcome. All right, flipping a coin is an experiment because there's more than one outcome, and both the dice and the coin, when you roll or flip, the outcome depends on chance. Okay, so that would be an experiment. A sample space is the set of all possible outcomes of an experiment. So for example, if you're rolling a dice, the possible outcomes would be rolling a 1, 2, 3, 4, 5, or 6. All right, so 1 through 6 would be your sample space. If you're flipping a coin, your sample space would be heads or tails. That's the possible outcomes of the experiment. Next we have a trial, which is a single observation. So if I roll a dice one time, that would be a trial. All right, so each time I roll the dice, it is a trial. So it's a single observation. And then whatever you get from the trial, that is called your outcome. So if you roll a 6, the outcome was a 6. All right, that's what happened. If you flip a coin and you got a tail, then the outcome was a tail. All right, so the outcome is the result of just one trial. Next, we have an event. An event is a possible outcome of a trial. All right, so this is a little bit different than sample space. Sample space is the set of all possible outcomes. So again, if you're rolling a dice, all possible outcomes would be 1, 2, 3, 4, 5, or 6. An event is something that could happen. So you could get a 2. So an event could be rolling a 2. Or an event could be rolling a 5. Or an event could be rolling a 6. All right, an event could be rolling a number 4 or greater as well. So it doesn't have to be just one number per se. It's just a possible outcome. So it could happen that you roll a 4 or greater. So that could be an event as well. And notice that it's different than an outcome. An outcome is the result. So an outcome is what actually happens. An event is something that could happen. So be aware of the differences between all of these terms, as well as the similarities. Okay, next we have the word probability. So probability is the chances or the odds of something happening. So to find this probability, what you're doing is you take the favorable outcomes and divide it by the total possible outcomes. So if you want a little equation, we have here the probability of event A. So probability of something happening is the favorable divided by the total. All right, now what does this mean? Okay, so example 1. So a die is rolled, and we are to determine what is the probability that the number that is rolled is greater than 3. All right, so what we want to happen is we want to roll something bigger than 3, which would be a 4, 5, or 6. So that would be 1, 2, 3 things that we want to happen. So our favorable outcomes is 3, because there are 3 things that we want to happen. Now when you roll a die, there are 6 possible outcomes, right? There are 6 sides on a die. So the total outcomes, the total possible outcomes would be 6. Now by definition, probability is taking the favorable divided by the total. So we take 3 divided by 6, that gives me 1 over 2, and that is my probability. That means we have a 1 in 2 chance of rolling a number greater than 3. And we could convert this to a percentage if we wanted to. This would be 0.5 or 50%. So we can also say that there's a 50% chance of rolling a number greater than 3. Example 2. A die is rolled and we are to determine the probability that the number showing is between 2 and 5. So this word between does not include the 2 and the 5. So the numbers between 2 and 5 would be a 3 and a 4. So the number of favorable outcomes would be 1, 2 things that we want to happen. So favorable outcomes are 2. When you roll a die, there are 6 total possible outcomes. So to find the probability, I take the favorable divided by the total. So 2 over 6, which can reduce to be 1 over 3. So we can say that there's a 1 in 3 chance of rolling a number between 2 and 5. And if we wanted to write this as a percent, this would be 0.3 repeating. So that would be 33.3%. Move the decimal place over 2 places. So either way we want to write this, we have the same solution, either as a percent or as a fraction. Example 3. Here we have 2 dice that are rolled, and we are to determine the probability that the sum of the numbers are less than 5. Alright, so when you roll the dice, the first dice could be a 1 and 1. For the second dice, it could be a 1 for the first dice and 2 for the second dice. It could be 1 and 3, 1 and 4, 1 and 5, 1 and 6. Alright, or the first dice could be a 2. So we have 2 and 1, 2 and 2, 2 and 3, 2, 4, 2, 5, 2, 6. And then do the same thing for 3, 4, 5, and 6. So the first dice could be a 3, first dice could be 4, it could be a 5, or it could be a 6. So if we fill this table in all the way, down here we're going to have 6 and 6. So notice we have 6 rows and 6 columns. So 6 by 6, that means the total things that could happen would be 36, right? So we could have done that without going through all of this. We can just realize that dice 1, so dice 1, there are 6 options. And then dice 2, there are 6 options. We multiply 6 times 6 to get 36 total. And that's using our fundamental principle of counting. Either way, we have 36 total possible outcomes. Now the favorable outcomes are the ones where the sum are less than 5. So we have to think through which sums would be less than 5. Well, notice all of these, 1, 1, 1, 2, 1, 3. If I add those together, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. All of these have a sum that is less than 5. Looking at this other column, if the first dice is a 2, it could be 2, 1, and 2, 2. Both of those add to be less than 5. Looking here, we have 3 and 1. That would also be less than 5. So what I have is 1, 2, 3, 4, 5, 6 favorable things that we want to happen. So 6 things that we want to happen, one of those 6. The total is 36. To find probability, I do favorable divided by total. So 6 over 36, which would give me 1 over 6. So the probability that the sum of the numbers are less than 5 is 1 out of 6. As a percent, I can write this first as a decimal, and then I can convert to a percent by moving the decimal over to get 16.66%, which would be about 16.7%. So either way we want to write our answer, it doesn't matter. These both mean the same thing. Okay, one more example. Here we are told that 2 dice are rolled, and we are to find the probability that the sum of the numbers is 6 or 7. So we already know the total possibilities of rolling 2 dice is found by doing 6 times 6, which is 36. Okay, there's 36 total possibilities. Now the question is, what is the favorable? So we have to think through what set of numbers would give me a 6 or a 7. So if I roll 2 dice, if the first dice is a 1, the second dice could be a 5, and that would give me 6 as my total. So let's make this little column here. This is for 6. Other ways to get 6 would be 2 and 4. We could do 3 and 3. The first dice could be a 4, and second dice could be a 2, which is different, by the way, than 2 and 4, because here with the 2 and 4, the first dice is 2. Here with 4 and 2, the first dice is 4. So it's 2 different outcomes. And then same thing, if the first dice is 5, the second dice could be a 1. So all of those would work to give me a 6. To get a 7, I think through which possibilities would give me 7 back out. So if I do a dice, the first dice with a 1, second dice with 6, that would add to give me 7. I could do 2 and 5 to get 7, could do 3 and 4, could do 4 and 3, could do 5 and 2, or 6 and 1. So these are all my favorable outcomes. So let's count these up. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 favorable. So 11 favorable, put that over the total. So my probability is going to be 11 over 36. And if I wanted to, I could convert this into a decimal, then to a percent, and that would be somewhere around 30%.